Welcome to Predicting Grant Applications, an introduction. After completing this model, we will have the ability to use all of the parallel processing power of a Spark cluster to fit and evaluate machine learning models. This can be dramatically faster than working on a laptop or even a large multi-core server. Contrary to what we did in the other modules, in this module we will not repeat the script we have run in previous lessons. After completing this lesson, we should be able to understand in a general way the data available in the grant application dataset, appreciate the problem being solved, and propose some features that might be good predictors. The dataset we'll be looking at contains 8,708 grant applications from the University of Melbourne, 3,992 of which were successful. There were 17,594 researchers involved in those applications, and the data is available on Kaggle. Our goal is to understand what features contribute to a successful grant application, and we would like to build a model that can successfully predict whether an application will be successful or not. Here is some of the grant data that's available in the dataset. Now, the original dataset from Kaggle has additional information, but we've dropped several columns in order to simplify this example. Some of the grant data that we're looking at includes the grant application ID, which is encoded as an integer, the grant status, this is whether or not the grant application was successful or not, the contract value band, this is the amount of the grant bucketized into ranges, and this is encoded as a string, and grant category code. Also encoded as a string, it is the categorization of the sponsor. For example, Australian Competitive Grants, Cooperative Research Centre, industry, etc. Now we have some data about researchers. So this includes the researcher's role in the proposed research, their date of birth, their department number, and whether they have a PhD or not. More data about researchers that we're looking at includes the number of successful grants, the number of unsuccessful grants, and the number of articles published in journals of various quality, A2 being the most prestigious and C the least. And here is the basic setup. Note that users running Windows will have to download the dataset to a local file in some other way because the shell command wget won't work for you. Now, the original data from the university, as distributed by Kaggle, is quite messy. So we've cleaned the data and joined the data about researchers and grants together into a single table. We're using the Spark CSV package from Databricks to load this tab-separated CSV file. In case you've downloaded the file elsewhere, please change the load path to the location on your local machine. And if you're trying this out on a cluster instead of a local machine, move this file to HDFS. And here we're showing some of the columns from the dataset. These include the grant application ID, the role the investigator plays, whether they have a PhD or not, the number of successful grants, the number of unsuccessful grants, which journals they've published in, and the grant status. For some of the grant applications, like number 3, we have many rows of data in this data frame. This is because there are many researchers collaborating on this one grant application. There are also many cases where the data is missing. Before we continue to the next lesson, let's have a think about a few things. First, we want to include features that are a good predictor for each grant. We also want to create features about grants using the data about researchers. And we would like to understand which values in the dataset might make good predictors. Having completed this lesson, we should be able to understand in a general way the data available in the grant application dataset, appreciate the problem being solved, and propose some features that might be good predictors.